Hey everyone, this is Mark Phillip, and today I'll be doing a Unity 3D tutorial on how to create a splash screen that will fade between multiple images. The point of this tutorial is more to illustrate how coroutines work, and hopefully you'll learn something from it. The only thing you should need to get started is the Unity program, and I'm using two images that I'm going to be cycling through, just my company's logo and some random wallpaper I found on Google Images. I'll just be using those and cycling through them. You can use whatever you want, but just make sure those are in your project. And I am on Unity version 5.3.4 F1. So let's get started on that. The first thing I want to do is create a UI canvas. So go up to Game Object, do UI, and choose Canvas. If you don't know, canvases are basically where all of your UI elements go. And that's what we're going to use to put our UI image on. So on the canvas in the hierarchy, I'm going to rename this to splash screen just for clarity. And then I'm going to make sure over here under render mode, I'm going to select screen space camera. I'm not going to go into these different options, but basically screen space camera means that our canvas is always going to be within our camera that we specify. It will always be within the viewing range of that camera, and it should follow along with it. So here where it says render camera and you see none camera, I'm going to drag and drop the main camera object onto that. And what I'm going to do now is right click on splash screen, choose UI, and choose image. And I'm going to rename this image to splash image. And you can see the image right here is just a white box. And what I want to do is resize this. So grab the the handles here on the sides, and to activate this, you click on this button up here. And I'm going to drag these out to the edge of the canvas rectangle, and you'll feel it snap when you get there. Once it snaps, just put it into place, let go. And this is so that the image basically occupies our whole screen. And over here we have the image script. And we're actually not going to really do anything with this. This is all going to be dynamically updated. So now what we need to do is create a script that will do all of this functionality for us. So on the splash screen object, I'm going to go add component. And in here, I'm just going to type, let's just call it splash screen. We're going to choose new script. We're going to select C#. I'm going to name this splash screen, hit create and add, and now we have our splash screen script. So let's go ahead and open this up in mono. And for clarity, I always get rid of this stuff and change my indentation a little bit. Okay. First thing I need to do so we can use the UI the UI library, is do using uniengine.ui. This allows us access to all of the different UI image or UI text elements and things like that if we want to control them via scripting. And the other thing I'll use is using, unityengine.scene management. And the reason I'm doing this is because I want to use the scene manager to basically load the next scene after our splash screen plays. So the first thing I want to do is create an image variable. I'm going to call it UI image, and then a canvas variable called parent canvas. UI image is going to be our actual image UI object that we just created, and that variable is basically going to dictate almost everything. Then what I'm going to do is do serialize field, and I'm going to put sprite images. Serializing a field in Unity basically means that you can keep this variable in the line below it. You can keep this variable private, but you can still edit the field from within the inspector in Unity. So if I save this real quick and I look at my script here now, there's an images variable with a size on it. The only reason I can click on this under the inspector is because I'm serializing that field. The only other way to do that would be to make this public, but usually you don't want to make a lot of things public just for security reasons in your game. So our images are basically going to be the pictures we want to use. or cycle through, I'll put it that way. We're using an array because this allows you as the developer to basically say, maybe you want 10 different pictures to cycle through, right? Like maybe you're doing a loading screen and you want a handful of pictures to just keep cycling through while you're loading. Maybe you want 10 pictures. You can do that by using this array of sprites. So then another thing I'm going to do is put in a variable option for allowing the user to click a mouse button to proceed to the next image. So I'm going to do bool click to proceed. And you'll see how that works later. And then here I'm going to add variables for our fading in and out time. So we'll do float fade time. This will be amount of time it takes to fade an image. That's what that's for. Oh, sorry, this needs to be serialized as well. All of these need to be serialized. The reason I'm serializing these is because it allows you as the developer to add this script into any scene and be able to just modify all these settings in the inspector and just have a fully working splash screen with all of the settings that you want. And then I'm going to do a serialized field float display time. This is going to be amount of time a non-transparent image displays before fading out. And then I'm going to do another serialized field, and this is going to be float transparent time. And this is going to be the amount of time an image stays transparent before fading in. So with that should be all our variables. And if I save it real quick, I look at my script. Now I have all these things here. So click to proceed. What we'll end up doing with this is if you turn it on, it will allow the user to dictate when the next image displays by left clicking. Fade time will be how quickly or how slowly do we want the fade to occur. Display time will be how long do we want that solid image to show before fading out, and then transparent time is how long do we want an image to stay transparent before fading into the next image. So that one's pretty much the opposite of display time. Now, what I want to do is in the start function, I'm going to do some basic stuff here. So parent canvas equals get component canvas. And what this is going to do is basically make sure that, all this is doing is assigning parent canvas to the canvas object that our script is attached to, which is this. And then underneath that, I'm going to say if parent canvas.world camera is not equal to camera.main, then we need to set parent canvas's world camera to camera.main. So the reason for this is in case you throw splash screen into a scene and it does not have a render camera assigned to it for whatever reason, this code right here is essentially going to make sure that you always have a camera assigned. It's just kind of a small detail so you don't have to deal with an error if it pops up, and it just makes it easier for you to throw the prefab into a scene and start using it. All this is doing is assigning our UI image to our UI image object, which is a child of the splash screen canvas. So we're using get component and children to grab the image object. And then we're going to do UI image.sprite equals images 0. So we're basically setting the first image we're setting the base image, I should say, of our sprite to the first index of the array that we created above, called images, which is going to be dictated right here. So to actually see how this works, let me save this. Under images here on your script, you can expand that out, and I'm going to do a size of 2, and you'll see both elements pop up. Both of them are looking for a sprite. So what I'm going to do is my first sprite's going to be my company logo, and the second sprite will be this wallpaper I downloaded off Google Images. And basically what this line of code right here is saying is to set our default sprite as this image right here, because this is element 0. So we're putting this all in the start function so that it just starts off that way right off the bat. And then the last thing we're going to do is type start routine cycle images. And we still need to make cycle images, that's why it's red. But what this is going to do is when the scene starts, the coroutine to cycle starts. So a coroutine is basically a function that allows you a certain level of control over its execution. A function typically will execute everything at once within a frame. So say, for example, I'm in update and I have cycle images. I just tell it to run. And I have like a cycle images function down here, like void cycle images, do something. What update's going to do is every single frame it's going to call cycle images, and every time it does, every single thing that is within this function will be executed. So what that means is essentially you can start taking pretty big performance hits in your program. Because every single frame, say you have 20 different functions which accumulate to like 700 lines of code running an update every single frame, that means every frame you're executing like 700 lines of code at once, which could be doing any number of different things, and it could start to hinder your performance. With a coroutine, we're able to control basically the amount of time we want to spend within a function before we return back to it and continue. And this will make more sense. If you're unfamiliar with coroutines, it will make more sense as I fill this out. So let me get rid of this nonsense I just wrote. So to create a coroutine, you use the IEnumerator type, and then you put cycle images. So IEnumerator is kind of like the equivalent of if I did void cycle images, right? Or if I did like int cycle images. The IEnumerator is just the return type of this function, and that's how you create a coroutine. IEnumerators allow you to use what they call yield statements, which allow you to stop the flow of the function for a certain amount of time. So the first thing I'm going to do is, if you remember, I have that click to proceed option. I'm going to have basically two conditions in this coroutine. One says if not click to proceed. So we're saying if we don't want the user to click a button to proceed through the splash images, we're going to execute a certain kind of code. And then we'll have an else statement afterwards. But let me go through all this first. And this is a little bit long. I'll try to explain as much as I can. So here I'm going to do a for loop, and inside I'm going to do int I equals 0, I is less than images.length, I plus plus. So inside of this for loop, I'm going to be executing quite a bit of stuff. I'm going to do UI image.sprite equals images I, and UI image.color, and I'll explain this stuff after I write it out, equals new color UI image .color.r, UI image.color.b, whoops, .b, UI image.color. Oh, sorry, I got that mixed up. It's supposed to be RGB. I have RBG. UI image.color.b right there, and then in here we are going to do 0. So basically what we're doing here is we're saying our UI image sprite equals whatever, equals the index of images for whatever I is. So I starts off at 0. So right off the bat, this is saying that our sprite is set to the 0 element of our images array, which is my company logo over here. And it might seem redundant because I already did that in the start function, but the thing is, when this coroutine executes, you have to have this here because as this increments, this is what's going to basically change our image to the next image in the array when we fade. And then here what we're saying is we want to start the image off fully transparent. So this is all the same color values as our image currently is, with the only exception being that we're at 0 transparency. So then what we do here is, we utilize the power of the coroutine. So now we hit yield, return, new, wait 4 seconds, transparent time. So what this statement's going to do is it tells the coroutine to actually stop execution and wait for this amount of time. So transparent time currently is only 0 seconds, but if I make this 2 seconds, then this is actually going to wait for 2 seconds before it executes the next line of code. As for the next line of code, we're going to say for float alpha equals 0, alpha is less than 1, alpha plus equals time dot delta time divided by fade time. This for loop is executing an alpha change essentially. So we're saying float alpha 0, continue to execute while alpha is less than 1. While alpha is less than 1, we will be incrementing alpha by itself plus time.delta time divided by fade time. Time.delta time divided by fade time is essentially making sure that we are having a smooth transition over the amount of time that fade time has specified. It's kind of confusing because time.delta time is basically the amount of time since the last frame was rendered. So you usually use time.delta time to keep track of time within the game, but you often have to combine it using using multiplication or division with some other variable to make sure it works properly. So if I change fade time over here in my inspector to say 2 seconds, so this is basically saying alpha is being incremented to the value of 1 over the course of 2 seconds. That's essentially what my calculation here is doing. And this happens every single time the loop iterates. It's running that calculation. So what this allows us to do is in here I can say UI_image.color equals new color. And to be honest, I'm just going to copy this line from line 55 and put it here because it's a lot of the same stuff. I don't want to type as much. But instead of the 0 on the alpha value, I'm going to use the alpha variable that I create in the for loop. So what this is saying is basically while our alpha is not full or at 1 is the full value of alpha in the color constructor. While it's not full, we will be basically executing this for loop over and over until it is full. So this is our fade in, essentially. That's what this for loop is doing. Fade in for loop. That's what this is doing. And then what I do is I say yield return null. Yield return null pauses the execution of the coroutine for a frame, and then it returns back to the coroutine. This makes more sense for executing a transparency change like this because we want to see that change occur every frame. We don't want to stop for we don't want it to do it like once every 10 frames or something like that because the result would look choppy. So instead we're saying to wait for a frame and then execute again. Wait for frame, then return to execution. Now again, because this isn't a for loop, even though the coroutine pauses here for a frame, it knows to pick right back up from this spot and move on. So after that frame executes, what we're doing is going basically to the next line, which means we go back up here. Our alpha is now incrementing again, and our fade image is going to be incrementing by alpha yet again. So this is going to result in a fading in of the full image. Now, after this for loop, what we want to do is say yield return new wait 4 seconds, and we're going to do display time. So if you remember, display time is how long we want the full image to display on screen. So if I go over here in the inspector, maybe I say 2 seconds, right? I'm just doing 2 seconds everywhere here. I'm gonna call this test scene. Sorry, I was saving my scene just now. So this line, based on our inspector, is saying to wait for 2 seconds. Now you can change this to whatever you want, but the reason we put it here is because once this for loop's done executing, that means that we're at full form, that we're seeing the full image in full color, full alpha, right? So as a result, we're looking at yield return new, wait for seconds. We want to wait for however long we want the developer to look at the full image. And once we're done looking at that image, we're going to execute a fade out. So let's go fade out for loop. And we're going to do for float alpha. Literally this is practically the same thing. I'm going to copy the for loop I just made. I'm going to paste it. The main difference is we're changing the condition from alpha less than 1 to alpha greater than 0. Alpha greater than 0. And we're making sure alpha starts off at 1. And then we're doing alpha minus equals time.delta time divided by fade time. So we start our alpha at 100% while the alpha is greater than 0, which means we're not fully transparent, right? So basically, while we're not transparent, we'll be decrementing our alpha value, and we will be changing our UI image color to a new color with the decrementing alpha value in it. And at the end of every iteration of the loop, we wait a frame before returning our execution. So this is going to be our fade out, and this is pretty much all the code we need for the basic fade in and fade out to work if we don't have click to proceed checked. And after this for loop executes, it's going to basically go up to the parent for loop because we haven't finished our, say, the length of our array. And it's going to re-execute this, and then it will wait for the transparency. So what this is going to do is basically go to our next image, keep it transparent, wait for the 2 seconds, and then we'll execute the fade in again. One thing I didn't mention was our outer for loop is based on the length of our array. So int I is basically starts at 0, which is our first element of the array. As long as I is less than images.length, we continue to increment. So this allows us to add 1,000 images to this array if we wanted to. And so if I save this and run it right now, it should work. Let me see. So I've got both my images set up here, size of 2 on my images array. I have click to proceed unchecked, which is good. I have 2 seconds set for each one. So if I hit play, so my image just starts empty and then it fades in, holds for 2 seconds, begins to fade out for 2 seconds, holds for 2 seconds, swaps the image, fades in for 2 seconds, sits for 2 seconds, fades out for 2 seconds, and it's done. So that's the very basic cycling of the images. Now, I'm going to go a little bit fancier with it because I think this is a little bit fun and interesting. What I want to do is allow, after all of this stuff is done, after we've cycled through all of our images, I want to load to a new scene. So this is what I made. This is why I use the scene manager library up here at the top, using Unity Engine.scene management. Here I'm going to say scene manager.load scene. I'm going to say scene manager.get active scene.build index +1. This is going to basically say load the next scene that comes after the scene we're currently in. And the way this is dictated is if you go under File, Build Settings, you'll find the scenes that are in your build here, and this is what the scene manager references. So if I hit add open scenes, it's going to add my test scene. But maybe I want to create a new scene and call it test scene 2. And I can go build settings. I'm going to save this. I'm going to open up test scene 2, go under file, build settings, add open scenes. Now test scene 2 is index 1 of my scene manager. Now if I go back into test scene and look at my script, basically this is saying to grab the current scene's index and increment that by 1, and that's the scene that will be loading. So that's that for the click to proceed part. Now what we can do is an else statement that says if we want the user to be able to click to proceed through the images, and pretty much what I'm going to do is copy the code I just had. And instead of if, I'm going to do else if And I'm going to take off the not and just say click to proceed. Or sorry, instead of else if, I'm just going to do else. And then in here, we're going to keep the same code here and the same code here, here. Most of this stuff stays the same. The main differences come in right here where it says display time, yield return new weight for display time. What I want to do instead is say yield return start coroutine wait for mouse click, and I need to create the wait for mouse click coroutine. So down here, yeah, down here I'm going to create IEnumerator wait for mouse click, and all this is going to have in it is while not input dot get mouse button 0 yield return null. My bad. So on the else statement, make sure you take the parentheses off. I forgot about that. So this is basically saying while the user's not pressing the mouse button, don't do anything but keep looping. So this is essentially an infinite loop until the user presses the left mouse key. When the user presses the left mouse button, then this coroutine is finished running. And what this line here is saying is to basically wait for this coroutine to finish running. So the only time that this statement finishes execution is when this condition is met. Or sorry, when this condition is not met rather. So when the user presses left mouse button, this statement is going to detect that and then it will continue execution. This is how we allow our splash screen to hold on the image until we press left mouse button. And then this part here, the rest of it's pretty much all the same thing as what we had up here. So now if I save this, all my errors are gone, and I click on my splash screen, I'm going to choose click to proceed. So now if I hit play, what should happen is my screen will fade in and my image should stay here. It's not moving, it's not changing. So even though display time's set to 2 seconds, it's not taking that because of the condition I made in the coroutine. Now if I press left click, my fade starts. And then it goes to the next one, fades it all the way in. And then it will sit there for however long we want. And then if I left click, it's gonna go, and then I'm loaded into my new scene. So that's the gist of coroutines. Hopefully you see how you can control execution using the yield return statements. It's really useful for a lot of different things in Unity. The big deal here is the saving on performance. Instead of all of this code executing in a single frame, if you were to just run it straight up from update using a normal function, this allows you that control and it allows you to save on your performance when doing these things, and it makes for a nice fading effect. So with that, hopefully you learned something from this. I will post a Dropbox link in the video description with the script in it if you don't want to type all of this out from the tutorial. If you'd rather just copy pasta it and take a look at it, that works. So hopefully you learned something. Check us out at studica.com. All of our links for social media are in the video description. So thanks for watching. Have a good day.